Hi. In this video, we are going to look at problems on conic sections, which are basically ellipse, parabola, and hyperbola. And we are just going to discuss the theory for these different types of curves through some problems. So what is the general meaning of these curves? You can define all the three different curves using the same definition, which is locus of a point P which moves such that the distance of P from a fixed point, which can be called S, and from a fixed line. This fixed point is the focus, and the fixed line M is the directrix. Is in a certain ratio, and that ratio is known as the eccentricity of the curve. So you have PS by PM is equal to E. If E is less than 1, it is an ellipse. If E is equal to 1, it is a parabola. And if E is greater than 1, it is a hyperbola. Now, all the three curves can be represented. If you follow this definition, you will be able to show that they can be represented by 2-degree equations like this. 2-degree equations in X and Y. This 2-degree equation can represent parabola, ellipse, hyperbola. It can even represent pair of straight lines and circles. And this is standard coordinate geometry theory, right? The things that we have learned in the previous videos, like how to make the tangent to a conic section, we have learned how to make tangents to circles at a given point. All of this applies directly to ellipse, parabola, hyperbola as well. So I'm not going to dwell too much on the theory because many of you might be aware of the basic theory. I would just give you a recommendation. SL Loni is the best source to learn coordinate geometry. SL Loni, Elements of Coordinate Geometry. So you can look at the conic sections chapter from that book. We will dive right into the problems and we will discover whatever we need to learn through the problems. Okay. So this is question 1. The left focus of x square by 9 plus y square by 5 equal to 1 is F1. A straight line L that passes through F1 and intersects the ellipse at 2 points A and B, and the coordinates of a point Q are minus 9 by 2 comma 0. So we have a straight line that passes through F1, which is the left focus of this ellipse, and it intersects the ellipse at 2 points A and B. So basically the line L is a chord of the ellipse. And we have a third point Q, which is minus 9 by 2 comma 0. If QB vector is perpendicular to AB vector, find the slopes of all possible straight lines L. All possible such straight lines, we have to find the slope of those straight lines, right? So the graph looks somewhat like this. This is an ellipse. The left focus will be here, F1, We have a line through it cutting the ellipse at 2 points. One point is A here, and one point is B here. We have a third point on the ellipse. Okay, I'll just draw the figure again. Not looking great. So this is the situation. This is the left focus. This is F1. This is A. This is B. And on the axis of the ellipse, this is the x-axis. There is a point -9/2, 0. And you will notice that -9/2, 0 is outside. This is the point Q, because this point on the ellipse is -3, 0, and this point is +3, 0. Because a square for the ellipse is 9, so a is equal to 3, so this is -3, 0, and this is 3, 0. Now we have been given that QB, if you join QB, it is perpendicular to AB, right? Okay. We have to find the slopes of all possible lines L. Our line L is this line. This is the line L, right? Okay. So now here, the focus here F1 will be -AE, 0 and AE, 0, right? Focus F1 and F2. You should find that. So eccentricity of the ellipse is √1 minus 5/9. So that is 4/9, so 2/3. So the focus here is -AE, 0 is one focus and AE, 0 is the other focus. So this becomes -2, 0 and 2, 0. So this is -2, 0, this point, F1. And this is 2, 0, right? So we can say that, let's say the line F2 or angle F2, F1A, let's say F2, F1A, this angle, let's call it as theta, right? So if this angle is theta, then F2, F1B, this angle will be pi minus theta, pi minus theta. So if we call mod of BF1, or the focal distance of point B from here, that is equal to, let's say it is T, right? If BF1 is T, then by property of the ellipse, BF2 should be equal to 2A minus T, 2A minus T, and A is 3, so it is 6 minus T. Why is this true? We know that the ellipse is also the locus of all the points, such that the sum of their distances from both the foci should add up to the major axis. Basically, we have BF1 plus BF2. Since B lies on the ellipse, should be equal to 2 times A, and A is 3, so it should be 6, right? So since we are calling BF1 as T, we are getting BF2 as 6 minus T, right? Great. Now, what I want you to notice is in triangle F1, B, F2, we can make this triangle. In this triangle F1, B, F2, we know the length of this side. This is 4. We know this is T, and we know this is 6 minus T, right? Great. So we can apply cosine rule here on this angle, which was pi minus theta, right? So I'll do it on the next screen. I will say cos of pi minus theta should be equal to 4 square plus t square minus 6 minus t whole square by 2 into 4 into t. We are doing cosine rule on this triangle, and we get basically minus cos theta is equal to 16 plus t square minus 6 minus t whole square. So minus 36 minus t square plus 12t by 8t. T square gets cancelled and you have 12t minus 20 by 8t is minus cos theta, right? So we can actually solve from here, like divide by 4, you'll get 3t minus 5 by 2t is minus cos theta. And this becomes 3 by 2 minus 5 by 2t. So 5 by 2t is equal to 3 by 2 plus cos theta. And multiply by 2 by 5. So 1 by t is equal to 3 by 5 plus 2 by 5 cos theta. So basically you're getting 1 by t is equal to 3 plus 2 cos theta by 5. And from here we get t is equal to 5 by 3 plus 2 cos theta. And remember, t was the angle, t was the focal distance of BF1, right? Correct. So, I mean, what we have here is, if I redraw the figure here briefly, I'll just redraw the figure for your reference. So we have this situation. This is, let's say, F2. This is F1. This is my A and B. This is B, right? And we have joined this. And we said this angle is theta, and this angle is pi minus theta. This distance was t, this distance was 6 minus t, and this distance was 4, right? Okay, and Q was somewhere here, Q, right? If you look at triangle QBF1, this is 90 degree, QBF1, this triangle, we can say that BF1, this angle must be theta, so BF1 mod should be equal to QF1 cos theta. It's a simple right angle triangle QBF1. So BF1 is QF1 cos theta. And now QF1, we already know the length of this, right? Because this was minus 9 by 2 comma 0 and this was minus 2 comma 0. So this length is basically 5 by 2. So it is 5 by 2 cos theta. That is your BF1. So we're getting T is equal to 5 by 2 cos theta from here, right? And we are also getting here T is equal to this. So we can equate the two different versions of T. So 5 by 2 cos theta is equal to 5 by 3 plus 2 cos theta, right? And we get a nice quadratic equation in cos theta. If you simplify, you will get, oh, I have made a mistake here because it was not 5 by 2 cos theta, it was 5 by 2 cos theta. 5 by 2 cos theta. So 5 by 2 cos theta is equal to 5 by 3 plus 2 cos theta. And simplifying it a little bit, you will get 2 cos square theta plus 3 cos theta minus 2 is equal to 0, where you get cos theta can be half. Since we have taken this angle, the roots of this equation are what? Cos theta could possibly be, let's factorize it and see, 2 cos square theta plus 4 cos theta minus, okay. So one of the roots is minus 2, which is not possible, right? One of the roots is not possible, only this is a possible root, which implies theta can be equal to plus minus pi by 3, right? So since it cannot be negative angle here, you will take the positive angle. Theta is plus pi by 3. And that means the slope of the line, this line slope, can be tan theta is equal to root 3. You could also have a situation where you have a line like this, where the slope is minus root 3. The slope of the lines could possibly be root 3 or minus root 3. You could have the same situation happening like this, right? Q here and B point is here and A point is here. So we have solved this question actually by just geometry and knowing that the sum of focal distances of B to each of the foci adds up to 2a for an ellipse, right? We figured out the focus positions and then we applied this property and did cosine rule in this triangle. We already have a right angle triangle on the other side, so we were able to find an equation on theta, right? So this is a slightly different approach to the problem. You could do it by the coordinate geometry method also, but I just wanted to show you how you can employ geometry as well. So that should hold you in good stead in questions that you will encounter in the future. Let's move on to the next one. So given the point A, which is 2 comma 1, let the right focus of hyperbola x square minus y square by 4 equal to 1 uh, okay, I don't think this is the correct way to frame it. So we have a hyperbola x square minus y square equal to 1, and the question says that this point 2 comma 1 is given, and let P be a point on the right branch of the hyperbola. Okay, this is the way to write the question. Let P be a point on the right branch of the hyperbola, and we have to find minimum value of AP plus PF, where F is the right focus of the curve. Okay, so what we have here is we have a hyperbola. Hyperbola will have two foci. Let's say this is the hyperbola. It will have two foci. Let's say this is F dash, this is F. We have to take the right focus, right? And P is a point on the right branch. Let's say this is the point P, and we have another point A somewhere here, right? We have to find the minimum value of AP plus PF. So PF is basically this. PF is this and AP is this. We have to find the minimum value of these two, the sum of these two, right? Now let's see what information we can gather from the equation of the curve. X square by 1 minus y square by 4 is equal to 1. So we can see A is 1, B is 2, and the value of root over A square plus B square is equal to 5, root 5, and we have eccentricity will be equal to root 5 by A. So eccentricity is root 5 here. Eccentricity is 1 plus B square by A square, root over, right? So that comes out to be root 5. Now that should help you find the focus. The focus F will be AE, so it will be root 5 comma 0, and this would be minus root 5 comma 0, right? And A is the point 2 comma 1, and P is any point on the right branch of the hyperbola, right? So if I want to find the minimum value of this, what I would say is I can do triangle inequality here, right? How triangle inequality? We have AP modulus plus PF modulus will be greater than equal to, one second, before we do that, instead of AP and PF, I can write it as equal to AP plus PF dash minus 2A. Why? Because just like in the previous question, here the distance P to F dash, we have property of hyperbola PF dash minus PF is equal to 2A. So therefore PF is equal to PF dash minus 2A, right? What is 2A? 2A is in this case simply 2 because A is 1, right? So we have AP plus PF is equal to AP plus PF dash minus 2, right? I will do it here. AP plus PF is equal to AP plus PF dash minus 2A, which is equal to AP plus PF dash minus 2. Why is this better for us? Because if I directly try to do triangle inequality on this, I know that the sum of two sides is greater than the third side, and APF, I will have to say it is greater than the AF, right? Correct. But now what we will say is, we would have said it is greater than equal to AF, but now here I will get AP plus PF dash, AP plus PF dash would be greater than equal to AF dash, right? AF dash. I'm doing triangle inequality on these two sides. Since this is a longer side, I get a more strict inequality here. Here I would have gotten an inequality, but that is not the strongest statement that you can make because the distance AF is much smaller, right? So that's why I'm trying to do this. We can try out this also, but you will not get a strong inequality in that case, right? So here, what we are getting is greater than equal to AF dash minus 2, right? Now, AF dash is how much? AF dash is 2 comma 1 to minus root 5 comma 0. So that will be root over 2 plus root 5 whole square plus 1, which is equal to root over 10 plus 4 root 5. That is my AF dash. So this is greater than equal to root over 10 plus 4 root 5 minus 2. This is what I'm getting from this side. If I had done direct triangle inequality, I would have gotten greater than equal to AF, which would be root over 2 minus root 5 whole square plus 1, which is 4 plus 5, 9 minus 4 root 5, so 10 minus 4 root 5. This is 10 minus 4 root 5, right? So ultimately, you are getting this is greater than this or greater than this. Now, which one you choose? You should choose the bigger value because that is a stricter inequality. And I think this value is bigger, right? 10 plus 4 root 5 will be roughly what? 10 plus 4 into 2.236. 2.2 into 4 is 8.8, so 18.8. So 18.8 will be greater than 4. The root is 4 point something minus 2, so it is greater than 2, this value. Here, we'll get 10 minus 8.8, so obviously it will be very small. So the answer for this question, we have to find the minimum value of this, right? The minimum value of this, it is greater than equal to this is a stronger statement, right? How are we doing it? We are doing it by the property of the hyperbola that difference of focal distances of a point from the two foci of a hyperbola is equal to 2a, and then we are doing triangle inequality, right? So by that logic, we have gotten this. Hopefully you have understood what we have achieved here. Let's move on to the next one. Yeah. The next one is this. A and B are common vertices are the common vertices of x square by a square plus y square by b square equal to 1 and x square by a square minus y square by b square is equal to 1. P and Q are variable points on the hyperbola and ellipse respectively. Hyperbola and ellipse respectively. We also have, which they satisfy the relation AP plus BP is lambda times AQ plus BQ, where lambda belongs to real, lambda mod is greater than 1. This is the condition that is satisfied by P and Q, right? First step is proving that OPQ are collinear. O is the origin here. So the figure looks somewhat like this. There is a hyperbola here. The vertex of the hyperbola is A and B. And the vertices are shared with an ellipse. So there is an ellipse here in the middle like this. And O is the center. Now, what we have is 2 points P and Q. P is on the ellipse and P is on the hyperbola and Q is on the ellipse. So let's say P is here and Q is here. So we have to join AP and BP, and we have to join AQ and BQ. And what is the condition that is satisfied? AP plus BP vector sum is lambda times AQ plus BQ vector sum, right? Okay. So how do we do this? This is the first part of the problem. Now think about it. We have AP plus BP can be written as AO plus OP plus BO plus B plus OP, right? We are splitting the AP vector as AO plus OP and BP vector as BO plus OP. That tells us that this is AO plus BO plus twice of OP. That is AP plus BP vector, right? Now think about it. AO and BO are vectors like this and like this. They cancel each other. They are the radius, or they are equal length and opposite directions, right? So these two get cancelled. So we have AP plus BP is twice of OP vector, right? And similarly, you can show that AQ plus BQ is also twice of OQ vector, twice of OQ vector. So the condition that the problem says is saying that AP plus BP is equal to lambda times this. So we are getting twice of OP vector is equal to lambda times twice of OQ vector. So basically 2 can be cancelled and we are getting OP vector is equal to lambda times OQ vector, which is obvious now that this is like a section formula situation when O, P and Q. So O, P and Q are collinear. We are getting OP is lambda times OQ and the vectors are having the same direction, so they must lie on the same line. So basically we have solved this part of the question just by a little bit of vectors, right? So that is the first thing. Then the second part of the question. The second part of the question says, if the slopes of the line, I'll just write it down. if the slopes of lines AP, BP, AQ and BQ are K1, K2, K3 and K4, then show that K1 plus K2 plus K3 plus K4 is a fixed value. Right. So to do this one, let's think about P and Q points. Let's say P is the point x1, y1, and let's say Q is the point x2, y2, right? Then we have P should satisfy the hyperbola equation. So we can say x1 square by a square minus y1 square by b square equal to 1. So multiply throughout by a square, you will get x1 square minus a square by b square y1 square is equal to a square. And you get an equation x1 square minus a square is equal to a square by b square y1 square. This is the relation that you get for P, and Q satisfies the ellipse. So in that case, what we are getting is x2 square by a square plus y2 square by b square equal to 1. So you're getting multiply by a square both sides, you're getting x2 square minus a square is equal to minus of a square by b square y2 square. This is what you're getting for the Q point, and this is what you're getting for the P point, right? So now, okay, what we can say is K1 and K2 were the slopes of AP and BP. So if you think about it, slope of AP and BP, so what is K1 plus K2? Let's write the slope of this K1. What is K1? K1 is, this is x1, y1, and this is minus a comma 0, right? So slope here is x1, y1. So it is y1 by x1 plus a, right? This is K1. This is the slope of AP. And what is K2? K2 is the slope of BP, and that would be basically, this is a comma 0, so it will be y1 by x1 minus a, right? So what we are getting is K1 is this, K2 is this. I will do the sum of K1 and K2. So I'll do it on the next screen. What is K1 plus K2? Is y1 by x1 plus a plus y1 by x1 minus a. So this becomes x1 y1 minus a y1 plus x1 y1 plus a y1 by x1 square minus a square. So this gets cancelled and you have 2x1 y1 by x1 square minus a square. That is the sum of k1 plus k2, right? Now we already got that x1 square minus a square is equal to a square by b square y1 square. This we already got because we saw that P lies on the hyperbola. P lies on hyperbola. So what is x1 square minus a square? We can put this here. So we get 2x1 y1 by a square by b square y1 square. So this gets cancelled and you get 2b square by a square x1 by y1. So we are getting k1 plus k2 is equal to 2b square by a square x1 by y1, right? Okay. Similarly, if you do the same thing for k3 plus k4, What was K3 plus K4? These were the slopes of AQ and BQ. You should get K3 plus K4 is equal to minus 2b square by a square x1 x2 by y2. By the exact same method, just follow the same method. So the addition of these two is becoming K1 plus K2 plus K3 plus K4 is 2b square by a square common. You're getting x1 by y1 minus x2 by y2, right? Now we have solved part 1 of the question where we saw that OPQ are collinear. OPQ are collinear means that slope of OP is equal to slope of OQ. Slope of OP and OQ being equal means y1 by x1 is equal to y2 by x2, right? So basically x1 by y1 is equal to x2 by y2. So this is equal to 0. We are getting this sum of all four slopes is adding up to 0, right? So that is a simple way to solve the problem. Uh, There's nothing very difficult about it. We just took points, took slopes, and then checked the addition and checked the conditions of the question, right? And then we are able to solve it. Let's do another one. This question says, let ABC, let ABC be three different points on y is equal to x square, and let R be the circumradius of triangle ABC. Find the range of values of R. So basically in this question, we have 3 points on a parabola and we have to find the range of values of the circumradius of the triangle using those 3 points. If you have a parabola like this and you take any 3 arbitrary points, this triangle will have some circumradius. We have to find the possible values of R, right? You should realize that as the parabola opens up and all, and as you go higher and higher, the triangles will become bigger and bigger, right? You should imagine a big parabola. If you go higher and higher, the triangles will become bigger and bigger. So R should not have an upper limit. So R will tend towards infinity as you go above as much as you want, right? So technically, if you were asking range of values of R, we just want the minimum possible value of R, or what is R greater than equal to, right? So that is our question. So let's say we have 3 points on 3 different points ABC, 3 different points ABC on y is equal to x square. So the points could be like this: x1 y1, x2 y2, x3 y3, and technically these points are x1 and y1 is x1 square, right? And x2 comma x2 square, x3 comma x3 square, right? So if a comma b is circumcenter of triangle ABC, then we can write equation of circumcircle. Equation of circumcircle would be, circle equation would be x minus a whole square plus x square minus b whole square is equal to r square, right? Why is this equation coming? Because equation of the circle would have been x minus a whole square plus y minus b whole square is equal to r square. but y is equal to x square, right? Because these 3 points are all satisfying the parabola. So this is my circle equation, and this equation has at least 3 distinct roots. This equation should have 3 distinct roots because we have said that these 3 points lie on the circumcircle, right? So now let's think about this equation. We have x minus a whole square plus x square minus b whole square is equal to r square. This is the degree 4-degree equation. A 4-degree equation cannot have 3 real roots because imaginary roots will occur in pairs. So we already know that it has 3 roots. So it must have actually 4 real roots, right? This is theory of equation stuff. If a 4th-degree equation we know has 3 real roots, then it must have 4 real roots because imaginary roots will occur in pairs, right? So let's say the roots are x1, x2, x3, x4, right? So now you can first expand this. You'll get x square plus a square minus 2ax plus x power 4 plus b square minus 2bx square minus r square is equal to 0. So taking all the terms properly, x power 4 and x square is here and x square is here. So plus 1 minus 2bx square, x is here and there is no other x. So minus 2ax, and the constant terms are a square, b square and this. So a square plus b square minus r square equal to 0. This is my degree 4 equation. So we know by Vieta's relation, sum of all the xi should be 0 because cubic term is missing. Sum of all the xi xj, where I is not equal to j, should be equal to minus plus. So 1 minus 2b, right? And product of all the xi's taken 4 at a time, or basically x1, x2, x3, x4 is equal to a square plus b square minus r square, right? Okay. Now we can see from here that we can say x1 plus x2 plus x3 plus x4 whole square will be sum of all the xi square plus twice of sum of xi xj, and this is 0 because this part is 0. We get 0 is equal to sum of all the xi square plus 2 times sum of all the xi xj. Since this is always positive, this must be negative because this is 0 equal to 0. Both cannot be positive, so this must be negative, which means 1 minus 2b is less than 0, which means 1 is less than 2b or b is greater than half, right? So this is the first piece of information that we are getting, right? And now using this a little more, you will get x1 square plus x2 square plus x3 square plus x4 square is equal to negative of 2 times summation xi xj. So that is equal to 2 times 2b minus 1, right? Okay. So let's do it on the next screen. We have x1 square plus x2 square plus x3 square plus x4 square is equal to 2 times 2b minus 1. But we know that by applying AMGM on these positive quantities, we know this is greater than equal to 4 times 4th roots of x1 square, x2 square, x3 square, x4 square. So greater than equal to 4 times root over x1, x2, x3, x4. So greater than equal to 4 times, and product of x1, x2, x3, x4 is a square plus b square minus r square, right? So what we are getting is 2 times 2b minus 1 is greater than equal to this, right? So we can square it after cancelling one of the 2's. Square it, you get 4b square minus 4b plus 1 is greater than equal to 4a square plus 4b square minus 4r square. 4b square gets cancelled and you are getting 4r square minus 4a square plus 1 is greater than equal to 4b. This is the relation that we are getting, right? So r square minus a square plus 1 by 4 is greater than equal to b, right? And we have already figured out that b is greater than half. We got that previously. So if I put this here, this is greater than half. So I'm getting r square is greater than a square minus 1 by 4 plus half. So r square is greater than a square plus 1 by 4, right? Because minus 1 by 4 plus 1 by 2 is plus 1 by 4. And therefore, we are getting a can be small, but definitely r will be greater than half, right? That is guaranteed. A could be 0, but the minimum value of r will be greater than half, right? So we have basically figured out the smallest possible circle radius for 3 points on the parabola y is equal to x square, and that comes out to be half. And the way we did it was mostly circle equation and theory of equations, right? So nothing very coordinate geometry like in our solution. We are using circle equation, theory of equations. We are using a lot of different concepts from other branches of maths in all of the problems that we have discussed today, right? So hopefully you learned something from this video. I will have a couple more videos on certain advanced topics in coordinate geometry. One video about parameterization and different parametric forms that sometimes are useful, and another video about families of curves. So stay tuned for that. That will end the whole coordinate geometry section of the course. Obviously, coordinate geometry is not super important from an Olympiad perspective. It is very rare that you will need that knowledge, but you better know it because sometimes you might find questions which are using some of the concepts here. Although it is very important from a JEE perspective. So if students are preparing for other exams, then this might be much more useful. So I'll see you in the next video. Next couple of videos will continue analytic geometry and we'll try and finish it soon. See you next time.